Introduction to Algebra. So far, we have learnt about numbers and geometrical shapes. What we have learned so far comes under arithmetic and geometry. Now, we are going to learn a new branch of mathematics called algebra. The main feature of algebra is the use of letters or alphabet to represent numbers. Letters represent not only a particular number. A letter may stand for an unknown quantity. By learning the method of determining unknowns, we develop powerful tools to solve the complicated puzzles and so many problems that arise in our daily life. To understand the basics of algebra, we need to perform certain activities. Now, let us see an activity. This is a matchstick. Now, let us make some patterns with these matchsticks which will help us to understand some important concepts of algebra. Now, we are going to make a pattern with a matchstick. We are going to make a triangle with matchsticks. So, how many matchsticks are required to make one triangle? 2, 3 matchsticks. To make a triangle, 3 matchsticks are required. So now I wanted to make one more triangle, that is 2 triangles. To make 2 triangles, how many matchsticks are required? For one triangle, 3 matchsticks, and for 2 triangles, 4, 5, 6. We need 6 matchsticks to make 2 triangles. Here is a table which lets us to know how many matchsticks are required to form the required number. So by looking at this table, we understand the basic pattern. Now, to know that n number, any number you give, any number of triangles, for example, I wanted to know how many matchsticks are required for 10 triangles. Here a basic thing we are observing. So for every number it is 3 times. For every number. For example, 4 triangles. For 4 triangles it is 3 times the number of triangles. So for example, 10 triangles, 3 into 10. 30 matchsticks are required. So whatever the number you take, that number is multiplied with 3. That is 3 times to that number of triangles, you get the number of matchsticks. So we can write that formula here. Number of matchsticks required. Number of matchsticks required is equal to 3 into number of triangles. In this way, we can find out the number of matchsticks required to the required number of triangles. Variable. Now let us learn about variable. Here is a face. To make this face, we need 2 black stickers. To make one face, 2 stickers are required. To make 2 faces, how many stickers are required? 1, 2, 3, 4. So we write 2 faces, 4 stickers. As we have seen the matchsticks activity, in the same way we write number of faces 2. In such case, number of stickers 4, and the pattern becomes 2 into 2. 2 faces, 2 stickers. Again, we take number of faces 3, sticker 6, 2 into 3. In this way, we can write for n number, so many numbers. Now, if we wanted to formulate it, we don't know the number of faces, but we wanted to tell how many number of stickers required. For example, for 6 faces, 2 into 6, 12. For 10 faces, 2 into 10, 20 stickers. For 12 faces, 2 into 12, 24 stickers. For m faces, so we don't know that exact number of the faces. So we use the letter m. M is a variable. It also acts like a number. That means all the arithmetic operations like addition, subtraction, multiplication, division, everything applies to this letter as like other numbers. But this is not a constant number. Okay, so m. For m number of faces, 2 into m. Because everywhere 2 into the number of faces. Then we get number of stickers. So here 2 into number of faces, m faces. So we kept m. So here it becomes 2m. 2 into m means 2m. It is not 2 plus m. 2 into m means 2m. So here m is the variable. That is number of faces. 2m. For example, I wanted to know how many stickers are required for 8 faces. So here 2m. In place of m, we substitute 8. 2 into 8, 16 stickers. So here this m is a variable. Expressions with variables. Let us see some example. Here are certain expressions in the form of statements. Here we have some statements. Let us see some expressions with variables. Here we have some expressions in the form of statements. Now see how to express these statements in algebraic expressions. So here the first one I have rupees 5 more than what Geeta have. More than what Geeta have. 5 more than what Geeta have. So we don't know what is Geeta having, but 5 more. So just we give the variable y to what Geeta have. Geeta have 5. Geeta have 5. So I have more than what Geeta have. So more than y plus 5. This is the thing I have. Y plus 5. In this way, we can convert the statements into expressions. Now we see how to write statements for expressions. Here are some expressions. Now see how to write the statements for this. 2p. Here Ravi has twice the money than Seema. 2p. Seema, the money Seema having is p. So Ravi is having twice 2p. Rules from geometry and mensuration. Perimeter of a square. We know that perimeter of a polygon is the length of all its sides. Now perimeter of a square. Is equal to square 4 sides. 4 sides. For example, you take a variable s for side. So perimeter of a square is equal to side plus side plus side plus side. So side plus side plus side plus side, that is 4 sides. 4 into s. So here we got the expression 4s, because the perimeter of a square side plus side plus side plus side. So all the sides of a square will be of same value. So we make 4 into side, any of the side. So here 4s, the s is a variable. So we will substitute the value. For example, side is equal to 3 centimeters. The side is equal to 3 centimeters. So 4 into 3, 12 centimeter is the perimeter of the square. So in this way, we can make the expressions using variables. Now we can understand more about the patterns from even arithmetic. Now let us see that even number pattern here. So here is an even number 2 and its pattern is written as 2 into 1. And look at 4, it can be written as 2 into 2. And 6 can be written as 2 into 3, and 8 2 into 4, and 10 2 into 5, and 12 2 into 6, and for 14 2 into 7, and for 16 2 into 8. So these are the patterns for these even numbers. So from this table we can understand that first even number is 2 into 1. The pattern for even number 10 is 2 into 5. The even number 14, 2 into 7. So we can write this pattern for any number. So for n number, what is the pattern for number n? We don't know that number n, it is a variable. We don't know the value. So what is the pattern for that? 2 into n, 2n. So this is the pattern. So for nth number, for 16th number 2 into 8, for nth number 2n is the pattern. Simple equations. Just recall this phases example. So there we found how to find out the number of stickers required for certain number of phases. So there we got a rule 2m. So m is the number of phases. By using this variable, we can find out the number of stickers required for a required number of phases. Say for example, here is a question: how many phases can be made with 10 stickers? 10 stickers. So how many faces can be made with 10 stickers? 10. So how to find out? 2m equal to 10. So how is this equal? 2m is equal to 10. 10 stickers. How many faces? The number of faces becomes that m. We use the variable m. 2m is equal to 10. Now we have to see that which value satisfies this m. That means we have to find out the value of this variable m. Okay, let us find out. Say for example, we take the trial and error method to see whether this equation is balanced or not. If m is equal to 1, 2 into 1 equal to 10. So this is not satisfied. This is not an equation at all. Because 2 into 1, 2 is not equal to 10. Now let us substitute m is equal to 4. Then 2 4s 8 and it is not equal to 10. Now let us take m equal to 5. So in place of this 4 we write 5. 2 5s 10 equal to 10. So here this condition is satisfied. 2m is equal to 10. This is satisfied here. That means m is equal to 5. So this is an equation made with some variables. So when we substitute 5 in place of m, this condition is satisfied. LHS and RHS of an equation. LHS left hand side and RHS right hand side of an equation. For example, 2m is equal to 10. We can call this as an equation when it is balanced on both the sides, on left hand side and on right hand side. So here we don't know the value of m. Say the value of m and its product with 2 must be equal with 10. Then only you call it as an equation. Otherwise this is not an equation. Say for example 2 in place of m we keep 4 equal to 10. 2 4s 8 not equal to 10. So this is not an equation. For a simple equation, both the left hand side and right hand side should be of equal value. So you can compare this left hand side and right hand side of an equation with a common balance. Now let us substitute 5 in place of m. 2 into 5 equal to 10. So now it is 10. So it is balanced on both the sides. Here the left hand side and right hand side having the same and equal value. So only these kind of things are called as equations. If we write 4 plus 5 greater than or 3 plus 6 not equal to 8, these are not equations. You cannot consider these as equations.